Hi everyone. Today I'm gonna represent you RSSI-based local positioning system, which is my capstone thesis. My supervisor is Raj Makarian, who is actually here, and my name is Barseghyan. So let me go through over the plan on what we are going to speak about: system concept of overview, system scope, constraints, limitations, hardware architecture, software architecture, and modes of operation of the device that I've already created. Motivation and the background. So we already know that GPS is very crucial for us for tracking, for navigation, but unfortunately not all these GPS can work very well, especially in the areas where GPS signals are banned or I don't know, they are terminated to work. So here we just come up with an idea that we can create a new product which is GPS independent for localization, and it can be used for critical and non-critical applications. Why? Because in the places where GPS is not working, there actually exists a huge gap of applications, such as military applications, as well as for some educational purposes. And as an inspiration, it was a continuation of previous year's capstone research project, Asik Arakelian's project. And I just used his academic idea and I implemented it to create a real-time operating system. And I created this embedded product. Let me go through over the working principle, overall how it works. So this is one branch of the system that we have. Here we have three static nodes, A, B, C, and I have one dynamic node. Static node, so it doesn't change its position, but dynamic node, it can go anywhere. So they, with this radius that we have here, they actually transmit and receive RSSI data, receive signal strength indicator. So based on the signal strength, they change this to the, convert this to the distance and measure the distance between the nodes. So they know each pair shows the node distance, and we can use it for our calculations. And this radius actually parse their RSSI value to the STM microcontroller, which I used here to get the values and do the logic, everything that I've created inside of this STM microcontroller. And it does the tree iteration logic, about which we will spoke later, and it outputs only LCD. Here is the visual how we can implement it visually, graphically. We can see them.
So, question: so someone has to know, someone has to have an accurate location for order this to work, right? Just one person, right? And the rest is just radio signals, right?
Yes, we assume that we know the positions of static nodes. This can be placed in our known positions, and with respect to these reference positions, we can calculate the position of this dynamo.
Oh, so these are static radio transmitters.
Yes, they doesn't change their position.
Pre-configured system. This is a pre-configured system.
Yep, I see. I thought it was something else.
System scope, constraints, and limitations, everything that we have. So we are pretty much familiar already about the system scope. It uses STM32 microcontroller, new MPRM version 2 radio models, and this kind of LCD. It calculates the real-time XY position of the dynamic node. This is again for a one branch. There can be a lot of multi-dynamic nodes. And visually outputs it on 128 by 64 graphical LCD. Some system constraints. It operates in the places where GPS is not working, or there is no any external positioning infrastructure. It requires manual configuration of static node coordinates. So in the place where we are going to do our tree iteration, we should already know the positions, the exact coordinates, and the distances of them of our static nodes. Designed for short to mid range. So for this is a military project. So for military project, up to 300 meters is the ideal case for the usage, but it can reach up to 70 kilometers. So we can use these radius capabilities for further very large scale projects, and requires pre-calibrated path loss exponent for each environment. These radius they are configurable. So distances that they measured. It depends on the receive signal strength indicator, so it can be, reflected, or there can be some obstacles depending on the environment, or there can be a lot of metal. So it should be pre-calibrated before using it in a specific environment. And it's actually a current limitation. Why? Because RSSI, it's not an ideal case that we have exactly very accurate, but in our logic, we are trying to somehow minimize the error, which I will show you. No rod housing. Prototype is not weather resistant yet. Why? Because this is a prototype. We're trying to develop this idea, create a device. Then in the further development, when we'll be integrate all of these parts in a single PCB, then we'll start thinking about the case, specific coverage, which will be used. And in this project, for full representation, full implementation of this project, we actually need 4 radios for 3 static nodes and 1 dynamic nodes. But in this project, we're using 2 radios to show that 1 branch is working, one just cycle is working, so it will work for all of them. Here is the circuitry that I've created. Here you can see this is the STM32 microcontroller and the pin configurations. This is the LCD that I'm using with its pin configurations. It is the power source. This is the LDO, which converts actually 8 volts to 3.3 volts, which will be which will supply the voltage for the PCB and the display. And this is actually used for PWM generation to regulate the backlight brightness of the LCD. I don't want to go too much on detail of the components since we already know them, but this is something which is new. I want to show this, the diagram of these radios. This is APRM version 2 radio modules developed by Engineering Sciences. They provided me for my capstone project. And here you can see the frontal and the front part and the back part of these radio modules that I have already created, assembled them. I also forgot to mention that here we have an encoder, which we can see there are some STM connections. This is for the future application. It will be connected to STM, but it will be for the user to kind of control the menu or to change the modes. This is actually intended for the user and will be helpful in the future. Now let us turn to the tree-literation algorithm on which our system is based. So in ideal case, in theory, let us discuss this case. So let us assume that we have 3 static points, P1, P2, and P3, and correspondingly, we have these circles drawn, which have R1 radius, R2 radius, and R3 radius. So in this case, we see that these 3 circles intersect at one point, and this intersection point is the point that that is required, that we're trying to obtain, and it has XY coordinate. So assume that these static points has correspondingly x1 and y1, x2 y2, and x3 y2.
Question?
Mm-hmm.
When I saw that, when I was reading your paper, actually, it may be difficult, but how about if you used, let's say you could only read 2 satellites, 2, not 3, 2.
That's in my project. I will discuss it later. I also consider that part too.
Sorry, I saw that.
So for solving this tree-literation problem, what we do, we are paying our attention to this system of equations, and let us kind of simplify this for solving this. So let's subtract the first equation from the second and the third, and we get this system of equations. Let's do some notations for being visually more comfortable. And here we can see that this is actually system of linear equations. So what we can do, we can solve it applying Cramer's rule here. So whenever we're applying Cramer's rule, we obtain x and y coordinate that is required for tree-literation logic. That's intersection point coordinates. But as I said, this tree-literation algorithm is perfect, ideal only in theory. In real life, it's even impossible to get these kind of measurements, and all the time we'll get some errors. Here you can see the result of these errors. They can even not touch the point or go further away from the point. Here you can see, and there is no actual intersection of 3 circles. There are points that intersection of two circles. So how we try to deal with this problem in my algorithm? I applied position correction algorithm post triliteration. So what it is, when we get the x and y coordinates after triliteration, but we know that there is some error, and we have also the RSSI data that we have already calculated, and we know the distance actually. So what we can do, we can actually measure the error, like subtracting from one to another to see is there any error or not, and applying that to see whether we have to push towards or go away from the static node. Again, we are changing here only the dynamic node. If there are cases when there are two dynamic nodes, we can actually split the movement into two nodes. So I think that would be perfect. Here is the mathematical representation, as we assumed here. A is the dynamic node and B is the static node. So let us, this is the AB vector which represents that line. So, and this is the normal that vector, which is actually the distance. And how we calculate the error? D current minus D measured. So within two values, we subtract them to see whether error is whether there exists error or not. So whenever error exists, we will also see from its sign in which direction we should push the point. So what we do, we get a unit vector for this AB. This is a unit vector, has a length of 1, and by this formula, we just push or pull a corrected version of the dynamic node. Here you can see error times weight times. Whenever error is negative, it will be plus. Here is the software overview. How I implement it in my software. Actually, I'm not going to represent the code by line, but with this flowchart, we'll go through this. First of all, it goes LCD clear buffer frame. We're just clearing everything in the buffer of the LCD and starting the new one. So defining the points, and at this point, I just inserted R1, R2, R3 as known values manually. I just write, for example, R1 is 3 meters, R2 is 2 meters, and so on. At this point. Then I call the triliterate function for the point A, and I see the results. Whenever it is succeeded, so it goes and maps and draws S1, maps and draws S2 and S3 respectively, the points. And then after drawing the static nodes, it draws the dynamic node and updates the LCD. After updating the LCD, it will be visually printed on our LCD. Whenever it's not succeeded, so it will display an error message and return back. So I have also created some algorithms for LCD to draw line on it, to draw circle, to draw rectangle with our desired parameters in our desired place. I think this will be very helpful for our future for this project in the future to create some graphical figures or line drawing algorithm. For drawing a line, I used Barseghyan's line algorithm, which effectively draws a straight line. Here, the thing is that this is I think this is the best way to deal with the display with pixels to draw a line. So what it does, it actually calculates it actually takes the 2 points, the start point and the end point, calculates the dy and dx, so changing y direction and changing x direction. Whatever changes higher, it takes a step in that direction, and on the other direction, it should know after each incrementation, it should go to the next pixel or stay in that pixel. That's the general algorithm. And in that algorithm, we use also LCD draw pixel. With pixels, we're drawing it. Rectangle drawing. This rectangle drawing is actually connected with the drawing the line, so we are using here lines to the previous algorithm that we have already created. And circle drawing, again, I use the Barseghyan's line algorithm, which actually splits the circle into 8 sections and mirrors them in separate sections. So we'll not do this for 8 sections, but we'll do for 1 section, and we will repeat the same for 8 sections. Now let us turn to the modes of the operation. This is the first mode, which is full geometry display mode. again, as I mentioned in my algorithm, I inserted values manually, like 5 meters, 3 meters, and it somehow determines the position of this. This is for 2 different values, just for abstract view. And this is actually a video how I can. Now we can see whenever I'm changing the relative position of radius, they actually visually can be interpreted in display, and also the distance will be printed too. This is I want to make sure that if I can work with this, change the differences, then it will be acceptable for all of them. Now the second mode of operation. Since this is a military application, we know that not on all environments there can exist static nodes. So we have to somehow deal with only dynamic nodes. So let's assume that we have a dynamic node only. So what we do here, generally, we take the first point A, we assign them the coordinate 0, 0, and we take the point B, and we know the distance actually between them, and we assign them to be in the same level, but having different x direction. So its x coordinate will be the distance between them. And we try and we continue the calculations based on this geometric structure. Here you can see how this is actually implemented. Here you can see the point A, point B, and let us assume that I pointed here point C, but in the previous version that was point C. Here you can see how it is done. Just compute the distance between 2 known points. So we know already the distance between them. So we can assign this A, and this is D minus A. So after derivations, the distance from point A to point K will be calculated. A here you can see how it is derived, and to get this the coordinates of this point, we should know how much we should go to the x direction and how much we should go to the y direction. So we know that we should go on the x direction by A, which is defined in this way. So we have to calculate also the h to see how much we should go up. And this is the h, and this is the final formula that we get. Now, when we get the point of C, now we have 3 pairs actually, AB, CB, and AC. So we know the distances between them. So to determine this point D, we can actually do not 1 3 iteration logic, but do 3 iteration logic to get more precise and better coordinates. And that's it. Thank you so much.
Questions?
Have you looked into the market if there's any commercial products available? Have you done some research on that?
Yes, I've done a lot of research. I noticed that they mostly pay attention to, they're mostly constructed with SDR platforms. Initially, we decided to do this with Addan Pluto, but after that, we decided to change it to make it more project specific. And in the project, there are a lot of products that are based on this SDR, but this is more project specific and can be developed very easily than SDRs.
Is there any speed limit for the device that's moving for the dynamic node?
Speed limit, it actually doesn't exist because
Because of the calculation. It exists.
yeah, it exists actually, but what I did for my LCD to work properly, I added some delay on it. So after 1 millisecond, it will update automatically.
It will update until the distance calculation is correct. If it's moving at the speed of light, or speed of sound.
Yeah, not a speed of sound. Of course, this is a military project, but
There is
for practical cases, it's
Hocam, you mentioned that, well, in your implementation, for all cases, you have to basically input the initial distances that you somehow. So let's say maybe if you have the static nodes, you and when you initialize your device, you have to know that you're a set distance from each other, right?
Mhm.
So have you considered some technique to maybe get rid of that with either some estimation or knowing maybe the power, you have an additional calculation of the estimate so that, when you turn it on, you don't have to basically go out and measure. Have you considered this?
Yes, I've actually considered this, but it pushes me to the direction to make it more global. So instead of having static nodes at a specific area, we can have something in a larger distance. So having specific centers for that, and from that centers we can actually measure the distances. I think it would be applicable for them.
So, can someone that attached to static nodes calculate your position? Let's say I have somehow access to the network of the static nodes. Can
No.
I know your position then? You are moving with the device, yes?
Yeah, but I forgot to mention that these radios have actually two modes of operation: single mode operation and hopping mode. So I think it would be hard. The hopping speed is 1,000 hops per second. So I think it should be very difficult to
If
catch
someone
the.
is connected to the network, our probably is asking if your system is hackable or not.
Still, yes, but in the future, of course, it will be protected.
So, but your static channels are not doing the calculation. They don't know your position. Only you are doing the calculation, yes?
Yeah. They are only receiving and transmitting the RSSI data, and with this device, I'm doing that calculation. The static nodes are intended only to use to measure the distance between them.
Even though this is a prototype, have you calculated current draw? And I think I saw you're using two 18650s, the batteries. Have you estimated how long will this operate non-stop at idle?
I've calculated for this radio it was 2 watts, the power, and for the LCD it was 0.25, I guess.
So,
And that's at idle or full operation?
Full operation.
Ասեք մենք էլ լսենք։
So, yeah, I think we have answered to my question. There is no way to know your position if you get access to all of the static nodes. There is no way to know your position because you are just receiving, you are not transmitting anything.
Static node is transmitting.
Static nodes transmitting, and he is only receiving it, and no one knows his position. Only he knows.
What if we
This is
spoof the actual R1, R2, and R3, the 3 nodes? Then what happens?
You can't figure there's only way is to get access to this device. Otherwise, there is no way to understand it because
No, not that device. Actually spoof the static nodes. So whatever the static nodes are sending to this device, you send it from a different location.
For example, we change the signal strength.
Yeah.
Hack and change the signal strength. That will be spoofing.
So he will get the wrong.
Yeah, he will go to the wrong
Right.
place,
understand.
right? I'm sure those things will be fixed.
I'm switching to Armenia for a short while. Կարենի ու Էդվարդի աշխատանքները օգտագործելով, որտեղ իրենք երկուսն էլ մենք ունենք 7 ուսանող, ով ավարտում է այս տարի ու պատիվ ունեմ ով ավարտում ու իրանց ապագան սպայական է։ Այդ 7-ից միայն երկուսն են, որ որոշել են, որ իրանք ուզում են բանակի մոդեռնիզացիայով զբաղվեն եւ իրանք military application-ով են զբաղված։ Շնորհակալություն Արմանին եւ շնորհակալություն պարոն Մակարյանին, որ այս աշխատանքները ղեկավարել են։ Մենք պատրաստվում ենք այս աշխատանքները վերցնենք ու գնանք ու պետությանը մեր ասենք, գիտեք, երբ որ դուք այսքան գումար եք ծախսում, որպեսզի սպա ստանաք ով նաեւ ինժեները, նաեւ այդ 4 տարվա ընթացքում պիտի պատասխանատվություն դնեք համալսարանի վրա։ Մենք որպես համալսարան գնալու ենք, ասենք, բա ինչ պատվեր եք տվել մեզ, որ ստանանք արդյունք, էլի։ Խոսքով եթե այս քննիթին եմ ընտրելու գնահատելու ժամանակ նաև մի հատ ունես մոդել հասկանանք ոնց անենք, որ այս աշխատանքները ոչ թե վերջում պատրաստվել ու սուպերվայզերները միայն աշխատեն, այլ նախապես գնանք, ասենք, որովհետև այս պատվերը պատիվ ունենի, տվել է պետությունը։ Իրանք են վճարում եւ Վազգեն Սարգսյանին եւ Համալսարանին, որ մենք ինժեներ սպա պատրաստենք ու ձևը հələ չգիտենք։ Մի քանի համալսարանների հետ է պայմանավորվել ենք, որ այդ մոդելը նենց ստեղծենք, միասին գնանք պետության մոտ, ասենք, տենց, շնորհակալություն։